a measure of the intensity of that sound. The intensity level of a sound determines how loud the sound is. So look at this. They are not the same thing. The intensity of a sound is the power crossing unit area containing that point. Whereas intensity level is actually the loudness of the sound, how loud the sound is. Now, how loud the sound is depends on the amplitude of vibration of the particles. Now, the intensity level represented by beta is a logarithmic function of the intensity and is given by, now, the intensity level, which is the loudness, is actually determined by the intensity. And there is a relation connecting the two. The intensity level beta is related to the intensity of the sound I by a logarithmic function. Well, you know what a logarithmic function is. Now, here is that function. Beta equal to 10 log I over I0, where I is the intensity of the sound whose loudness we want to find, whose loudness is beta. And I0 is what is called the threshold intensity. So here I is the intensity of the sound of which we want to measure the intensity level beta, and I0 is the threshold intensity. In other words, threshold intensity is the intensity of a sound that you can barely hear. For example, can you hear when you breathe? I'm breathing. I can barely hear. But there is a sound, because when you breathe, your nostrils are vibrating. And that vibration produces a sound. But you can barely hear it. And that sound, or the intensity of such a sound, is I0, called the threshold of intensity. And the threshold of intensity has a value for human ear. It is 10 to the power of negative 12 watt per square meter. So wherever you want the value of I0, always use this value, 10 to the power of negative 12 watt per square meter, and that is the threshold of intensity. Intensity level beta is measured in a unit called decibel. So beta is measured in a unit called decibel. Look at the way we write the decibel in short form. It will be small d, big B, decibel. Now notice that the difference between intensity I measured in watt per meter square and intensity level beta measured in decibels, they are not the same, although the intensity level beta is determined by the intensity I. Beta equal to 10 log I divided by I0. That's an important equation that connects the intensity level and the intensity of a sound. Now here I have a table. I don't know whether you can see all of it on your screen. Normal breathing is intensity level. The intensity level is 0 decibel. See, normal, well, barely audible. The threshold of intensity is 0 decibel. You see, that is not normal breathing. Normal breathing you can hear. Now you tell me that is not normal, that's abnormal. But normal breathing you can hear. It is 10 decibel. It's barely audible. What is the intensity level of threshold? Is 0. rustling of leaves is about 20 decibels. Now look at that. Busy traffic, 70 decibels. Heavy truck rolling by Niagara Falls is about 80 decibels or 90 decibels. Now, constructed noise is about 100 decibels. So you can see what will be the decibel value of my voice. You see, I normally speak very loud, and I know some of you must have actually had difficulty getting the volume adjusted, because when you open this video sometimes it blares out because I speak very loud. You got to control your volume so that the decibel value is more comfortable for you. Is that right? Okay, so I just gave you these for guideline only. Let's do another example. What is the intensity level of a sound wave of intensity I equal to 10 to the power of negative 10 watt per meter square? I have given you the value of intensity. I want you to find the value of beta, the intensity level. Alright, do you remember that equation I gave you? Beta equal to 10 log I over I0. You got the value of I, and you know the value of I0, don't you? I gave it to you. What is the value of I0? It is 10 to the power of negative 12 watt per meter square. So use the values of I and I0. That will be 10 log, I is 10 to the negative 10, I0 is 10 to the negative 12. Now what is 10 to the negative 10 divided by 10 to the power of negative 12? That will be 10 to the power of 2. So this will be 10 log 10 to the power of 2. Alright, is there anybody who has trouble with this? What is log 10 to the power of 2? Log of 10 to the power of 2 is 2. In other words, the decibel value is 20 decibels. And in my table, 20 decibel correspond to the rustling of leaves. When a breeze comes, the leaves rustles, about 20 decibels. Alright, let's do another one. The sound of a dog's bark is 50 decibels. What is the intensity of the bark? So, this time I gave you the decibel value. You need to find I, the intensity value. And the next part, the intensity of a rock concert is 10,000 times that of dog's bark. What is the intensity level of the rock concert? Alright, let's start with the first part. What are the things we know? You are given the intensity level, beta equal to 50 decibel. You need to find the intensity of that sound. Alright, I0 we know is 10 to the power of negative 12 watt per square meter. And we go out to our old equation, beta equal to 10 log I over I0. You know beta, you know I0, we need to solve for I. Well, if you know how to solve a logarithmic equation, which you do in your college algebra. Okay, let's do it. 50 equal to 10 log I over 10 to the power of negative 12. Now, what I'm doing here is I kept the 10 outside and used the properties of logarithm. That will be log of I minus log of 10 to the negative 12. You understand that? Log of A over B is log A minus log B. Alright, can you tell me what is this log of 10 to the power of negative 12? Log of 10 to the power of negative 12 is negative 12. There you are. So that will be 10 times log I minus negative 12 is plus 12. So you got 50 equal to 10 times log I plus 12. And that will be 10 log I, distribute that 10 log I plus 120. And what is this quantity equal to? 50. Alright, next take this 120 to the left side. Get 50 minus 120 is negative 70 equal to 10 log I. And therefore, what is log I? Divide both sides by 10. Log I equal to negative 7. Okay, if log I equal to negative 7, remember, when you write log, the base of this is 10. If the base is E, it will be ln. So log I equal to negative 7 means I equal to 10 raised to the power of negative 7. You should know that. So if log I equal to negative 7, then I equal to 10 to the power of negative 7. That means the intensity of dog's bark is 10 to the power of negative 7 watt per square meter. And now, if this is the intensity of the barking of the dog, what is the intensity of the rock concert? It is 10,000 times the intensity of the dog's bark. So the intensity of the rock concert is 10,000 times 10 to the power of negative 7. What is that equal to? That will be 10 to the power of negative 3 watt per meter square. And now you need to convert to this to decibel value, or find the intensity level of this intensity value. Again, I remind you, don't confuse between intensity and intensity level. Here I equal to 10 to the negative 3 watt per meter square. We need to find the corresponding intensity level. Alright, beta equal to 10 log I over I0. I here is 10 to the negative 3. I0 is 10 to the power of negative 12. Tell me, what is 10 to the power of negative 3 times 10 to the negative 12? Alright, that is 10 to the power of 9. So this will be 10 log 10 to the power of 9. What is log 10 to the power of 9? Log 10 to the power of 9 is 9. So this is equal to 90. The intensity level of the rock concert is 90 decibels. Okay, so I hope you have a fair understanding of the relation between intensity level. If I give you one, you should be able to calculate the other. Now, I'm going to continue this lesson as a second part. So I'm going to stop this one here. From pitch of a sound, I'm going to call it 1.4B. Alright? Okay.